Welcome you to my session. This session will be about securing microservices and moving them into the cloud with Kubernetes. And how to do that. The thing is, security is not easy to implement, and that's why I want to share you with insight of how to do this simply, and some clever tools that could help us offload some of this complexity and help us focus on business features in our applications. First, I expect most of you to at least have some notion of basic security patterns. This is not really deep down expert level presentation, but I expect something that some knowledge about basics. Then I'll talk about JWT or JUIT, depends on how people like to pronounce it. It's JSON Web Tokens. So if you know about this specification, it's easier to understand what I will talk about. But if not, just raise your hand when we come to that, and I'll try to shortly explain what JWT is about. And we'll be using OAuth, so it's good to at least have some notions. But I think most of you do, because you authenticate using Gmail to other services. So that's basically what's OAuth about. So feel free to raise questions, but I prefer if we can talk about things at the end. If you don't have anything really to the point, I'll try to save enough time at the end to have a discussion. So as I said, security is not very easy. I assume most of you know that your application needs to be secured somehow. I don't know if you feel confident to write a code that secures your application. How many of you would like to write security from scratch or implement it, or how many feel confident that they would do it right? Not so many. I think there are more. You're just probably too shy. But I don't think, even though you're capable of doing that, I don't think you would find it easy to implement something like two-factor authentication. I think it's much better now. Thanks. So we'll get to how to implement this easily with the help of some external services. It's good if we can really reuse what's there, because then it helps us focus on what's important. It helps us if we use already existing patterns and tools. It helps us implement best practices in securing our applications. If we are going to secure microservices, which is even harder to do than securing a monolithic application, we need to again think about how to do that, how to secure calls between services, and that's not easy, as we'll come to that, because microservices are distributed, they are mostly stateless, and you probably need to carry some authentication token here and there to identify who's the caller and what permissions they have. So in the end, there are some identity platforms that can help us solving most or all of these problems, and leave us to focus on what is important for us, and to implement easily authorization of our users, to allow some users or with some privileges to do some actions, but deny the action to some unauthorized users or people or users without these privileges. And these identity platforms allow us to do this securely. So the most valuable thing about them is that they already implement best practices. Even their documentation explains the best practices, even though there are some options to do the security authentication. especially some of those services. One is Auth0, which I will talk about. Has very decent documentation which explains into detail all the options and implications. So it's good to read the documentation to understand what is good and what are the implications of doing things in a particular way. So, and they are also compliant. Most of these are compliant with some standards. There are security standards with OAuth, which I mentioned. OpenID Connect is another one. And most of these already implement both standards, so that you can easily switch to the implementation without really changing your application. One of these solutions is Auth0. There are some more. Most of them are hosted as a service, so you don't have to install them. But there are also some solutions that you can install in your environment as a server and authenticate using them. So it's up to you what you choose. For this presentation, I chose Auth0 because it's very easy to use. It's hosted in the cloud and it's very developer friendly, and it has nice documentation and easy to use console. So it's easy to do a demo with it. Auth0 also provides single sign-on, which means that if you have multiple applications, you allow your users to authenticate once, and when they jump to another application with a different URL, they don't have to log in again. They receive the same security token, and they are able to just move across the applications without always signing in, always trying to remember what is the password for each application, because the authentication is shared among them. There are some nice features in Auth0, like breach password detection. So these are the things that you wouldn't even think about if you try to implement in your application. They try to care about what's going on with your applications, with your data, and if there is a potential breach, Auth0 will detect it and inform you. It also implements multi-factor authentication out of the box, and integrates with external services, some of them out of the box, but it also allows adding connectors, so you can create your own connectors, plug them in the hosted service, and use any service out there, or even your own service to authenticate. And there are some more. But in particular, I like the last one, which is ease of use and developer friendly. It's easy to get started with, and they also have nice pricing model, which they only charge for active users. So even if you have like millions of users signed in or in your database, if only 50 of them are using your application during a month, you are charged only for 50 users, which is nice. When we get to microservices, it's extremely helpful to have an identity management platform like this, because for microservices, if you want to make secure calls between them, you need to secure every call between microservice, and the critical part is how to authenticate. You usually authenticate a user, which is calling a user-oriented service. But then this service calls another service, and it doesn't end there. The other service can call another service. But there's no way how to authenticate later. You have to pass the authentication information across the services. And one of the ways to do it is to use JW tokens, because these allow to encrypt the authentication information, so the client can authenticate against some issuer, for example Auth0. It will receive a token which is already encrypted and signed, so that it can't be modified. It can just send the token to another service. and the service decrypts the token. It can validate it against the same issuer which issued the token. And what is important, this token already contains the permissions. So the permissions are not stored in the database. The permissions are given from the issuer, for example, Auth0. So the token doesn't only identify the user, but also identifies the roles, basically the permission that the user has. And the token then can be passed across the calls of the services. So there's one more step to do, is that the service needs to propagate this token when it calls another service. So there is the chain of calls, and every call is passing, propagating this token to another service. So the security context remains the same from the point when the user authenticating, for example, via the browser, through all the service calls until there is a response coming back to the user. So this is what JWT allows very easily, because it contains everything needed, and it can be used in stateless environments. You don't have to remember any session data, any authentication information, what you previously used to do, or maybe you probably do right now with monoliths, where you authenticate using user password, you get a token, but the server needs to remember the token and needs to remember which user it belongs to. This is a stateful behavior. If you want to scale to multiple services, you have to replicate this data or put them into cache. With JWT, you don't have to do that, because the token itself contains everything. It's encrypted, and that's the reason why it's safe. Another reason which has to be met to make it safe is that there is an expiration date for the token. The token is created for some time, and when the time passes, it's invalidated, or is invalid, and the client has to request a new token. Doesn't mean that it has to log in again, but the client needs to access the identity provider, Auth0, retrieve another token, and if they had valid session with the identity manager, then they just receive the token under the HUD. The user doesn't need to know anything. It's just when you go into to see the contents of the token, it's different. But it contains the same privileges, same user interface. It's just same information. It's just updating with new expiration date. JSON web tokens are compatible with OpenID and OAuth in the way that they can be authentication tokens in these standards. The JUIT is itself specified with RFC 7519, so it's a web standard which specifies the format of the token. It is basically a piece of text separated into three parts: a header, payload, and signature. And the payload is a JSON object which contains information about the permissions and the user, and expiration date and things like that. And in the end, it's encrypted in a way that the signature then validates that there is a proper checksum for the JUIT. In the JWT, there are some standard claims, which means there are some standard pieces of information in the JSON data, the JSON payload. You can add more if you want, if it's possible on the back end and in the service to decrypt the token and read more information. It's up to you if you want to put there. So usually the most important thing for authorization is the list of groups which are in turn mapped to user roles. So far about general security and using JWT to authenticate between microservices. For people, for projects using Java, I want to also show how MicroProfile set of specifications for Java applications fits into this type of pattern, how it makes it easy to implement JWT authentication between services. And just to do that, I'll start with explaining what MicroProfile is. It started a couple of years ago as an extension to existing Java standards. Those of you who are not new in Java ecosystem know that there are some standards that usually were created within the JCP, Java Community Process, which was backed by Oracle. All these specifications were pretty common or are pretty common in the Java world. The problem with this is they don't evolve at the pace that sometimes these new challenges in the cloud infrastructures or patterns like microservices or reactive applications need. So a couple of years ago, there was a need to really bring something more experimental or more innovative that evolves more quickly than the traditional standards. And basically the same body, same companies behind Java EE created this project to evolve some APIs within Java enterprise ecosystem faster than the Java standards. Meanwhile, Java EE was renamed Jakarta EE, moved to Eclipse Foundation, where MicroProfile is also a project in Eclipse Foundation. So these two activities are now converging together, but it will still take some time because they have different pace of innovation, evolution, and also different processes behind them. But they very nicely fit together because Java EE and MicroProfile APIs can be used together. And now there are, as similar to Java EE, also with MicroProfile there are several implementations. MicroProfile is just a set of specifications like interfaces and descriptions of the contracts with these interfaces. And multiple implementations try to implement this, provide the functionality. You can choose many of them. I'll be using PyRMicro because I know it the most. I work with it every day for a couple of years, and I still like it. But you're free to choose any of the other implementations to try out. If you already know one of them, you can try it. It's probably best to start with something you already know. So I'm coming back to the JWT propagation. With the JWT, we have this flow. In the beginning, there is a client that authenticates or somehow retrieves the JWT token. Usually, I recommend to use some existing identity manager to authenticate securely and retrieve the token that can be validated because the identity manager is set as a trusted authority. So the called microservice or service, whatever the size of it is, can validate that the token is really correct and valid, and is not supplied by a third party who is trying to hack into our services and applications. In the JWT, there's the caller's identity, which is retrieved or read from by the service, and yeah, if you use these OpenID Connect or OAuth identity managers, you can offload the validation to some service that knows it better than you. And even if you know it better, you can rely on the service and save the time for something more reasonable. Shortly about Biomicro, because I chose it for the demonstration. It's a runtime that implements MicroProfile. It implements also Java E or Jakarta E APIs. It's container friendly, which means it's optimized to run in Docker, in Kubernetes clusters. It's optimized for fast startups and to be small, so that it's easy to work with, deploy to the cloud. And that's basically it for introduction. The rest of the session, I'd like to show you the demo, show you the code, how to do that, how to work with MicroProfile, how to implement the JWT authentication using Identity Manager, and finally how to get it running in the cloud using Kubernetes. Just to introduce the demo, it's 2 microservices and 1 service which is a front-end application, and it has also a REST backend. The reason is to have 1 single entry point for user, and then the web calls a REST backend, and the REST backend calls the other services. The important thing is that the front end, the web page, gets the authentication token, the JWT. So it has to pass it with every request. It passes it via authorization header, and this is not part of JWT, this is specified by MicroProfile. It's because the backend is implemented with MicroProfile APIs, this is Java backend, and it expects the JWT token in this authorization header. So the web application just puts it on the request, and then the backend automatically recognizes the JWT token, validates it, and reads the roles, and then validates if the user has access to these REST endpoints. And then, if it calls one or the other service, again, it takes the token, it reads the token from the request, and passes it to another REST call to these other services, so that the other services also have the same security context, same information about the initial caller and their roles. Yeah, and then in the end, I'm going to run it in Kubernetes. It is not so difficult, as I'll show you. In the demo, I'll be working with 3 users. There's admin user, and it's basically a conference-like application, an application that tries to track submissions, speakers, and attendees for a conference. It's very simple. It doesn't have, it's not very usable for production. It's just for demo purposes. But it works with 3 roles, and it's enough to demonstrate the configuration of roles, passing of the JWT token, and information inside it. So the admin can do basically everything. It can create sessions, approve speakers, and so on. There's a speaker role who creates, who submit them as speakers to the conference, and then there's attendee who can just see what are the sessions of the conference. So that's it. That's pretty premature. We'll come to the questions later, or if, in case you have questions now, just raise your hands. Don't be shy. So I'll jump first to the running application to show you what the demo is about, and then we'll go through the code and how to deploy it in Kubernetes. So the application is already deployed now in the Kubernetes. After I show you the demo, I'll try to clean it up and redeploy again so that you see the whole process. The web app, there are 3 services. One of them is exposed using an external IP address, so now we can access it from anywhere on where we can access internet. And there is a button. Oh, I'm sorry. What's wrong? I must have done something wrong. I'm sorry, probably. If I can fix it, I'll show you the demo. So I'll switch now to the code. I'm sorry, I won't show now the application now. But what the application does is after you press login, it redirects to Auth0 for authentication. So it will ask you to log in through Auth0 service. And Auth0 supports out of the box, and in the free tier which I'm using, it supports Gmail or Google authentication or user password. So you can choose, and if you have paid subscription, you can have much more options to authenticate. And when it authenticates, it sends back, it redirects back to our application and sends a token which we can then use to authenticate the service calls from the web application. So in order to implement this, there's a front-end application written in JavaScript with Vue framework. It's not very important that it's Vue framework. It uses just Auth0 client to do the authentication. That is Auth0 specific. But what is important, it retrieves the JWT token, and then it uses the token to call the services. So if we go to operations, here we can see for every call it adds the authorization header, which starts with bearer, and then there is a token. And the token is encrypted in base 64, and encrypted with, I think, RSI 256. So it's not easy to see what's in there, but if you inspect the call, you will see that there is this authentication header. Then the service receives it on the other side. And now we get into MicroProfile, into the Java world. Where the REST service is exposed as with JAX-RS APIs, as a JAX-RS resource. I'm not going to go to detail about JAX-RS API. It just exposes a service at URL at session, and then exposes methods, binds methods in the object to sub URLs and methods like post, get, and so on. And the important stuff here is there is an annotation roles allowed, which is, this one is not in particular from MicroProfile, it's just common annotation. It's in the package JavaX annotation security, so it's common in any enterprise application, anything that is a Java application, or possibly also in Spring applications, anything that supports these types of annotations. What is specific about MicroProfile is that it allows you to use this annotation on the JAX-RS resource, because otherwise it wouldn't be picked up, it wouldn't do anything. And there's one more thing to do. we need to specify the login configuration, which is MicroProfile JWT. This is just one line to add to our application configuration. We also declare roles that the application uses, which can be used in the resources, and that's it. There's some more things to do, but we'll get there. It's not very complicated. Here we specify roles which are allowed, so this session resource is accessible to every role, administration, attendee, speaker. From the nature of how JAX-RS works and the whole microprofile with dependency injection works, you can also specify these roles allowed and these annotations that restrict access also on methods. So on every method you can override this. If you don't, then the default configuration on the class is used. And then one more important thing is that we don't really need to authenticate on this level, because this is just a backend. It's accepting calls from the web application, but we need to pass this context to another service which actually does the thing, which is behind, hidden in the cluster, not accessible to the outside world, but our service, our backend needs to access it to do something. And in order to pass the security context, we can just inject security context. The JWT specification says that the JWT token integrates into existing Java EE APIs if they are present, if they are implemented. And Paramicro provides Java EE and Jakarta EE APIs. So you can inject security context. You can also inject JUIT directly with something like this. JSON Web Token. So you get the JSON Web Token object right there, or you can get it from the security context like this. You just get user principal, and the JSON Web Token implements the principal, and the specification says that if the JWT token authentication was used, then this principal can be converted to JSON Web Token object. So there are multiple ways how to retrieve this token. The easiest way is to inject it right here. Why do we do it? The reason is that the specification still doesn't cover the case when we want to issue a call to another service. I hope that in one of the newer versions this will be covered, and the JAX-RS client will automatically get the security context and propagate it. Right now we have to do it manually, but it's very easy to do. You can just create or initiate the JAX-RS client and retrieve the security context and retrieve the token from there and add it to the header. So this is what actually I do here on these 2 or 3 lines of code. We're adding the authorization header so to pass the same information we receive from the web application to the other service. Okay. And I really wonder why this doesn't work. Oh, I think I know. The reason is that when in the Auth0, this is, by the way, the console, or actually this is the console for specifying roles for users. I need to switch to the other one. This is a dashboard for Auth0, which allows us to configure basically everything we need outside of our application. Our application just needs to specify some information to be able to access to the Auth0 context. So in order to do this, we just need to provide 3 values. It's a domain that we need to create in the Auth0 dashboard. client ID, which is generated in the dashboard, and the audience, which is an API in Auth0. It's not very important to know what API is, it just needs to be created as a separate configuration in Auth0, and the name of the API is passed as the audience. This is basically what is transferred or sent to the client for Auth0. Here it's a JavaScript client. It uses this information to connect to the Auth0 service in order to authenticate. And then the rest is just in the console. So here we have an application defined, and in order to secure it tightly, Auth0 requires to specify the list of URLs that are allowed. And I think I restarted my Kubernetes cluster, and the URL now is different, so I need to put it everywhere to allow the URL, otherwise Auth0 gives me those errors. Yeah. Okay, so I hope that now, I'll try to reload. Yeah, it worked. I'll sign out just to show you the screen. So normally, I was signed in before, so it automatically signed me in. If I sign out, this is what I get. Normally, first time I try to log in. And as I said, we have two options now because I'm using FreeTire. There's Google authentication, and there's user password, and I can create a new user. And it's completely safe to allow creating new users because these users don't have any roles. So the administrator needs to go to Auth0 console and allow them actually to do something in the application. I already created these some of these users, so if I sign in as a speaker, I have some roles. Here we can show the token that we received from Auth0. And this is the payload of the JWT token. You see that maybe you don't see it clearly. I'm sorry for the colors. But the most important thing is here. It's the list of allowed roles in that field. That field has a strange prefix. I'll come back to that later, why it's that. But it's important that it has a role speaker. And it's exactly the role that we assigned here in the user management. If I go to the users, and to the user I used to sign in, it has a speaker role. So this is actually where I configure it, and when I configure it and the application requests the token, it gets the role already in the token. The catch is that the token is valid until it expires. So even if you reconfigure something in the dashboard, the token is still valid. And be careful to assign how long the tokens are valid if you really want to change roles on the fly. You can configure very short lifetime for a token, for example, a couple of seconds, or you can configure hours. It really depends on what are your requirements. Another thing is that until we reload, the application uses the same token because it requested one token and it tries to use it as much as possible. But the application is designed so that it doesn't store the token, doesn't store the state. So if you reload the application, we'll try to get the token again. The thing is, it's already authenticated. There's information in our browser, in the cookies, that Auth0 knows that we authenticated. So it won't ask for a new user password or Google authentication. It will just send a new token. So this is one way how to approach these situations when we want to really have fine control over when people have which roles. We can issue short-lived tokens and rely on the application to always get a new token very frequently. This is a kind of neat security measure. If you have an application which doesn't reload, you have to do that manually. You have to check when was the last time you requested for a token and request it again. This prevents security breaches. So imagine that somehow some intruder will get your token. They are allowed to do what the user is allowed to do, and it's very hard to prevent them access, because the token is valid until it's valid. There are patterns to disallow access, but you have to implement them on your own. Basically, the most common pattern is to implement the blacklist. So that is store the tokens which are still valid, but you want to refuse them to connect. So you want to pretend they are already invalid. So we have to remember the token and always match incoming tokens if they are on the blacklist, and then return HTTP unauthorized if they are in the blacklist. But you have to manage that on your own, and you have to be careful not to expose tokens to intruders. Okay, so with the demo, if we continue just shortly, now the speaker, because it's already authenticated with a token that has a speaker group, they can register themselves as speakers. So I'm going to register myself. I'm allowed to do that. What I'm not allowed to do is I can't confirm myself as a speaker. Although the button is there, pressing the button called another service, and the service realized that the JWT token doesn't have the administration role, so it doesn't allow the call. It returns HTTP unauthorized result, and we get this message. So in order to allow that, we really need to log in as an admin. And this time I'll use the Google authentication. So this is what you already know from a lot of services that redirect to Google to authenticate. You have that out of the box in Auth0, and you don't have to do anything to really implement it. Now I'm signed in as a different user. It's my picture, but it's a different one. And now the access token says it's admin. So as an admin, I can accept the speaker. And the last thing, I can log in as a plain attendee of the conference with just another user with user and password that I created earlier. And this time, because I configured the role in the Auth0 dashboard, the token only says it's an attendee, so it doesn't allow to even view speakers. If we attempt to view speakers, it doesn't allow add new sessions, even though the button is there. If we try, we'll get a message, but it allows to assign to the schedule of the talks, so to mark that we are attending the talk. So that's the demo in the nutshell. Going to the details, and not very deep details, but just to show you how it's implemented under the hood. There's some more aspects in Auth0 which if you try to implement this way you should know about. In Auth0, not all of the required claims for MicroProfile JWT authentication are present. most specifically the group information is not in the format as expected. I think it's not even there in the token, although it's present in the Auth0 service. So Auth0 service is very powerful to add this missing information. It has rules, and with these rules we can specify JavaScript code that adds the missing information. So basically, every time when a JSON token is generated, this code is executed on the Auth0 service. And one catch is that every piece of information we add to the token needs to be prefixed. So we chose our own prefix, and this may cause troubles with some microprofile implementations. In Pyre Micro, they realized this, and they have a vendor-specific option to specify prefix, which will be stripped down from the field. So in the end, there will just stay JTI and groups field in the converted token, which is as expected by MicroProfile JWT specification. In order to do that, you just need to specify one simple file. Where do I have it? Just enable namespace true, and it will strip down the Pyre namespace. Then the last thing, basically what we need to do is just to distribute these services as Docker containers and put them to Kubernetes to have our service up and running to the outside world. And in order to do this, since I'm using Pyre Micro, I can use the Docker containers which are provided by the project and maintained by the project out of the box. It's very simple. I'm going to put it into a Maven build, with Maven simplifies building everything just by one command. It builds all the services, creates Docker images, pushes the Docker images to external Docker registry, so that the Kubernetes cluster in the cloud can pull these Docker images and use them. But basically, what we normally would do is something like this. This is what we want to do. We base our image on existing Pyre Micro image. We can specify the latest version. Or actually, there is already 5.194 just released yesterday, but I didn't have time to really test that everything works there. I didn't want to screw my demo, just in case. But yes, it's a pretty nice release with a lot of new functionality, so I recommend to check it out. Then we copy our application, which is application WAR file. It varies from service to service, and we copy it to a directory predefined in the container already, or in the image, to make it easy to deploy without remembering the path where to store the image. And this is basically it. The default image just runs Pyre Micro, finds the WAR file there, and starts the application on port 8080. If you want, you can also provide some more options with CMD and override how it deploys the application, and some configuration options. For example, specify no cluster to disable distributed memory, and we can also specify exactly, it's deployed here, opt deployment application WAR. if you want to really specify, if we have multiple applications there or anything, the catch is we need to specify now the application that is deployed, because we are overwriting all cmd command in the Docker file, which specifies which application to deploy. This can be done also in from XML with Fabric 8 Maven plugin. So if you really want to automate this without running Docker build, Docker tag, you can put you can use this plugin to put the information in your Maven project. And this is basically the same what I did. I specify cmd from clause, and this is the way how to specify the copy commands. It's called assembly, and specify the list of files and directories where they should be copied to. So it's basically one-to-one mapping. When we run it, it builds all the services, builds Docker containers, applies the proper tag. This time I'm deploying to Oracle Cloud, to the Kubernetes cluster, so the tag needs to reflect the Docker registry in Oracle Cloud, and that's the only way how you would find out it's running on Oracle Cloud, because the rest of it is plain Kubernetes. We can start the proxy with kubectl proxy. And now I had to create a Docker registry in the Oracle Cloud. I won't show you, it's fairly easy. I just show you what's specific to Kubernetes, so that you can use it. You can use this in any cloud provider, any Kubernetes distribution. So for every service, we create deployment, which specifies our container, the image, the name of the service, and we can specify configuration variables. There are defaults in the application. This is also a MicroProfile functionality, which allows you to specify configuration in multiple ways, either as system properties in Java, or environment variables, or pluggable custom configuration sources. From the application point of view, it doesn't matter. The application just declares, I want this configuration with this name, and even can provide a default value if there's nothing provided, and it will work with the value that's there. It doesn't care how it's provided. It gives you much more power to change the configuration later without really changing the code over the application. And we specify the port, which is 8080 for every service. This is one more thing to add. If you want to link it to link our Kubernetes cluster to a private Docker registry, up front I created a secret in the cluster to link the Kubernetes cluster to the Docker registry, just with a simple command. And this is, I think it's even generated somewhere in the Oracle Cloud Console. I don't remember, but it was really easy to figure out. And we just declare that this Docker container should be pulled using this secret. And then we configure a service, which basically just exposes this service using a DNS name on a specified port. It allows us to scale the service, so if you want to really just cover some increasing load, we can scale in Kubernetes, and the other services will still just use the same name and port, and Kubernetes will load balance between all the instances. This is the same for all the other services. One different thing is for the web app, where we specify load balancer type for the service, which means that the service is exposed to external world via external load balancer, and it's assigned an external IP address. That's why we can access it, while the others are only visible internally. The others don't specify any type, which is by default is clustered, which means they are only visible internally in the cluster. And then in the end, we just apply all these services with apply f speaker service. I would have to remove the existing ones to make it happen. So I don't have much time. I want to give you some space for questions. But in the end, if we apply all these deployment files, we will get these three services interconnected together, able to pass the JWT token between each other and authenticate, retrieve the token from the Auth0 service. And this type of application should, if you know the APIs and know what to use, it takes just a few hours to implement everything from scratch. Okay. So now some time for questions, if you have any. Are you confident that you are able to now create applications with Auth0 or another identity provider? Seems like I did a good job, I hope. If you don't, you can still ask me questions. I'm here. I'm also at Pyra booth down there. I have some t-shirts here, but there are some more goodies at our booth if you want to stop by and chat about microservices or cloud. Just, I'll be glad to meet you there. Thank you.